Hello and welcome to the video lecture series brought to you by St. Andrews Institute of Technology and Management. In the series of lectures, we are discussing the subject called Data Structures 2 or Advanced Data Structures, and today we are going to start a new topic, a very interesting sorting algorithm called quicksort. Yesterday we have see what binary search is all about, and I have intentionally left one topic there called linear search. Now linear search, according to my view, doesn't demand a separate lecture because it's just comparing each item with every other item. So if I got the time and if I got some extra minutes in some of the lectures in this unit, so I will try to display to you what linear search is in that particular lecture. Otherwise else we are going to treat it as a non-topic. So today we are going to start with quick sort. So let's begin. Let's go ahead to the notes. So quick sort is also an algorithm that is based on divide and conquer. That means we are going to reduce our area of concentration to a smaller and smaller and smaller, let's say, memory places of your array which you want to sort. Uh, so let's see what I'm trying to say. How quick sort works. Now let's suppose you have this array and you want to sort it. By sorting it, I mean that I want this particular array such that the smallest value should be at the lowermost index and the highest value must be at the last index. That means 0 must be at the first index and 9 must be at the last index of the array. So basically in increasing order. Now to perform quick sort, the main thing to keep in mind is we have to initialize 2 or 3 pointers. Okay, if you are doing your coding in C, if you are not dealing with C or C++, you can also switch on to variables which can hold the value of the indexes. Okay, so instead of pointers, we can call them as variable. Let's say first variable holds the index value of this particular value, and second variable holds the index of this particular value. So pointers and the variables holding the index values can do the same work. That is up to you which language you have chosen to perform your task. Okay, so let's move ahead. Let's see how we can perform the quick sorting on this particular array. Now as you can see, this particular array is unsorted right now. It has started with 8 and then some random values and ended up with the last value at the last index equal to 2. Now, first of all, we have to choose a pivot element. A pivot element. Now, pivot element normally has been taken as the last element or the element at the last index or the rightmost index. Now, the pivot element means the element around which the array will move or the array will break. So, that is normally a meaning of the pivot elements. So now let me start with the pivot element. As I have already told you, the pivot element must be the last element of the array. So I will take the pivot element as the 2. That's why I have highlighted it. Now the 2 is the pivot element. Now how can you initialize this pivot element? If you're using your C language, you can initialize your pivot element by initializing a pointer, and that particular pointer variable will hold the address of uh, the value 2 or the last index. And if you're using some other high level language, let's say Python or Java, all you can do is you can store the index of this pivot element into that particular variable. Okay, so I have initialized the pivot element. Now the next step is the elements smaller than the pivot element are put on the left and elements greater than the pivot element are put on the right hand side. So that must be our main goal. Our main goal is we have to make ensure that all the elements to the left hand side of the pivot element must be smaller than the pivot element, and all the elements that are in value greater than the pivot element must be on the right side of the pivot element. Now at the beginning, when the array is not sorted, you can see uh, the elements which are greater than the pivot element, that is 9, 6, 7, 8, are on the right hand side, sorry, left hand side of the pivot element, and all the elements which are smaller than the pivot element, that is 1 and 0, are also on the left hand side of the pivot element. So we have to rectify that. So my intention is to reach to this particular point, the second point you can see here along with my cursor, that after performing the first iteration of your quick sort, the quick sort will sort your complete array in several iterations. So in first iteration you will see that now after first iteration, my pivot element has shifted, and has shifted such that all the elements which are of in value greater than the pivot element are on the right hand side. As you can see here, 8796 has now shifted to the right hand side of the pivot element, and all the elements which are smaller than the pivot element in value must be on the left hand side of the pivot element. So 1 and 0, which are smaller in value than the pivot element, which is actually 2, are shifted on the left hand side of the pivot element. So I have to go from there to there in first iteration. Then what we'll do, we will break this particular array into three parts. Now this part, the left hand side of the pivot element, will be the first part. Then pivot element alone will be the second part, and all the elements on the right hand side of the pivot element will be the third part. And then again, the first and third part of the array will again perform the same iteration, that is, they will choose their own pivot elements and again they will perform the same tasks. So this will keep on doing again until and unless there will be no elements to the right or the left hand side of the pivot elements. And when that happens, your complete array will be sorted out. Okay, so let's see what I am trying to say here. Now, a pointer is fixed at the pivot element. The pivot element is compared with the elements beginning from the first index, and if the element greater than the pivot element is reached, then a second pointer is set for that element. Okay, so what I have trying to say here is, let's begin. So the pivot element is fixed. Okay, now this is your pivot element. I will name it with P. I will initialize another pointer. This pointer will start from the rightmost side, and this is pointer number 2. And I will start searching from this particular element if the value of this particular element is greater than 2 or not. Okay, now 8 is greater than 2. Let's again read that. It will make more sense. Now pivot element is compared with the elements beginning from the first index. If the element is greater than the pivot element is reached, a second pointer is set for that element. Now the pivot element is compared with other elements, a third pointer. If an element smaller than the pivot element is reached, then smaller element is swapped the greater element found earlier. So let's see here. It has been more graphically more intuitive. What I have done is I have initiated a pivot element, that is 2, and first I will look to the rightmost side. And I will find out, I will try to scan each and every element from the left, sorry, I will scan from the left hand side, and I will scan each and every element starting from the leftmost side. And I will stop at that element which is actually greater than the pivot element, which in our case is the very first element. What I'm trying to say here is, suppose in this case it would be, let's say, if that is 2, let's say it would have been 1 here. Suppose, I'm not altering it, just I'm trying to make you people understand what I'm trying to say. And suppose it has been 0 here. So first, what do I have to do? After the initiation of the pivot element, I will start searching for from the leftmost side for the element which is greater than the pivot element. So basically, in this particular case, I have to search for an element which is in value greater than 2. So I will search for the leftmost element that is equal to 1. It is not greater than 2. I will move on to next. I will search the value, compare the value. On comparing, I will find out that 0 is not greater than 2. I will move to next. And in this case, I have found out the value to be 6. Now 6 is greater than 2. So my second pointer will be fixed here instead of there. So if this is my array, what I will do is, this would be my second pointer. This is going to be my second pointer. Okay, so this has been said in this A. Okay, the pivot element is compared with the elements beginning from the first index. If the element greater than the pivot element is reached, a second pointer is set. So this is what we have done. We have starts comparing with the first index, second index, and I have reached a element which is actually in value greater than the pivot element. Now a second pointer is initialized here, or a second variable is initialized which holds the index of this particular element. Okay, so now I think you must have understood. So I will undo what I have done this, because this is not our actual array. Okay, now in this case, because the very first element of the array from the leftmost side is actually greater than 2, so our second element will be initiated from here only. Okay, now the third point. Now the pivot element is compared with the other element, that is to the right hand side of the second pointer, and if an element smaller than pivot element is reached, the smaller element is swapped with the greater element found earlier. So what I am trying to say is, we have initiated a pivot element. We have started looking from the left hand side, most left hand side. We have found the element which is actually in value greater than the pivot element. Second pointer is here, as you can see here in this figure. The second figure has been initialized. Now I will start searching from the value to the left hand side of the second pointer, which is actually less than the pivot element. Please keep your focus on my words, that we have to search after initializing the second pointer. We have to search to the right hand side. Sorry if I have said left hand side, please pardon me. You have to search to the right hand side of the second pointer, and you have to look for the value that is smaller than this pivot element 2. Okay, so let's start. To the right hand side of the second pointer, we have value 7, which is not less than 2. We will have value 6, which is actually not less than 2. Then we encounter the value 1, which is actually less than 2. At this point, what we will do is, we will swap this value with second pointer. Okay, so the value 1 has taken the place of 8, and value 8 has taken the value of element 1, as you can see in this particular figure. Okay, now after the swapping has taken place between the 8th element and the first element, again we have to initialize we have to initialize new second pointer. Let me again say that we have to initialize new second pointer. Initially the second pointer is at this place. Okay, now the values have been swapped between 1 and 8. Now the new second element or new second pointer search will have the same rule as before. Now we'll start looking for the value which is actually greater than the pivot element starting from the leftmost side. Now from the leftmost side, I know first element is not going to be my second pointer because we have just swapped it. So we'll look for second value. Now second value 7 is actually greater than 2. So my second pointer is now at 7, as you can see here. So my new element has been, new second pointer has been initialized or been updated to this particular value. So let's get here. So what we have done here is, in the previous iteration we have found third here, and then we have swapped 1 with 8 and this with this. So the scenario now is, let me use some different color for it. Okay, let's now we have 1 here and we have 8 here. Okay, now I will remove all my third pointer and second pointer. Now the new task is I have to find or update the value of second pointer again, and again I will start with the same rule. In the first time what I have done is I have decided the value or the place of second pointer to that particular element whose value is greater than the pivot element. The pivot element is actually 2. So we'll again start looking from the leftmost side. Now from the leftmost side I know first element is not going to be greater than 2 because we have just swapped it. So we'll look for second element. Now second element has a value 7 which is greater than 2. So my new second pointer, let me again say that my updated second pointer is at this element which has a value 7, and again the same rule will be applied again. Now I will search for a value to the right side of the second pointer, that is from here to here, which is actually less than the pivot element, that is 2. So what I will do is, to the right hand side of the second pointer, I will, first element is 6 greater than 2. I will move on. Second element to the right hand side of second pointer is 8, which has been swapped in the last iteration, is actually greater than 2, so I will not go there. And next I will encounter 0. Now 0 is less than 2, that is the pivot element. So my third, let me again say that we have 2 pointers, second pointer 2 and pointer 3. Pointer 2 now has the value this particular. Now 3 previously has the value where 1 has resided. Now we have to update the value of 3. Okay, now 3 is now in this place. We have updated the value of third pointer, that is, or if you're using some high level language, the Java or Python, the index of this particular element. And again what we have to do is we have to swap the second pointer value with this third pointer value. So what we will do is, now value 0 will go at this place and 7 will go to this place. So your new array will look something like, we would be having 0 and we would be having 7. Okay, let's get back to the notes. I think I have displayed that. Okay, so here you can see 7, after initializing the second pointer with new value, which is actually index of this particular element, we have found out the next element which has to the right side of the second pointer, which is actually less than the pivot element. So 0 is there, we have swapped 0 with 7, 7 with 0, as you can see here. Again, I will initialize or update the value of second pointer. Now, second pointer will be will be initialized by again the same rule. I will start looking from the leftmost side, and the first value which I will found greater than the pivot element will be my second pointer. So 1 is not greater than 2, 0 is not greater than 2, but 6 is actually greater than 2. So this is my new value of second pointer. Okay. Again the same rule, to the right hand side of the second pointer, I will start searching for a value which is actually less than 2. So first element is 8, not less than 2. Second element is 7, not less than 2. Third element is 9, which is not less than 2. So now we have reached a point where all the iterations have ended, or the first main iteration have ended. At this particular point, what we have to do is, when we have reached the second last element of the array, that is the element next only to, or the previous only to the pivot element, it means now the point has come where we have to swap the values of pivot element and the second pointer. So now the values have been swapped or going to be swapped with the pivot element and second pointer. Now second pointer has a value 6, pivot element has a value of 2, so these value will be swapped. So now your pivot element has gone to this place and 6 has gone to this place. And if in a way you will see, you are finding out the value which is less than the pivot element, you have not found it, you have gone to the pivot element which is not less than 2 but actually equal to the pivot element. So at this juncture, when you have reached a point where the values to the right hand side, where you are searching for a value which is actually not greater than the pivot element, if you reach a point where or you can see where you have reached the pivot element itself, then at that point you have to swap the values of second pointer and the pivot element. Okay, this might be confusing, but if you practice it with your pen and copy, what I am trying to say here is you will find it easy. We are just repeating the same steps again and again. You first start a pivot element, then you start looking for second pointer or second element, then to the right hand side of the second element you start looking for a value which is actually less than pivot element. If you found one, swap the second pointer and the lesser value with each other, again start looking for the new second pointer. Where if you have found it, again start searching for a value which is less than pivot element to the right hand side of the second pointer. And if a point reach where you will not be able to find a value less than the pivot element to the right hand side of the second pointer, then in that case you will swap this pivot element with the second pointer, which has been done here in this point. We have reached a point here where we are not able to find a value less than pivot element to the right hand side of the second pointer. So now we will disintegrate this particular array into 3 parts. Now 1 and 0 will be first part, 2 will be second part, and from 8 to 6 will be third part. By disintegrating, I don't mean that we have to store them in different places. You have to initialize separate pivot element for these two arrays, that is first two element, first array, and this second array. You have to initialize separate pivot elements for both of these and again repeat the same procedure. So let's get ahead. As you can see, we are not bothered about this particular element, pivot element now, because it has found its right place. Okay. Now I'm bothered about to the right hand side of the pivot element and left hand side of the pivot element. So what I will do is I will again call the first iteration on both of these arrays separately. So again I will decide a pivot element for this particular array, and I will decide a pivot element for this particular array. I will try to find a pointer. Let's see this particular array first. So what I will do is I have initialized a rightmost element as the pivot element, that is equal to 0. Now I have to find out the second pointer. I will look for value greater than second pointer, that is 1. Now this is my second element. Towards the right hand side of the second element, I will look for a value which is actually less than pivot element. Now as you can see, we have no element here which is actually less than, to the right hand side of 1, which is actually less than pivot element. So this last step has reached already. So in that case, all we have to do is swap the second pointer and the pivot element. So this has been done here. Okay. And I think these two have found out their rightful places now. And again, from this particular array, let's go to the second array now. 6 has been assigned as the pivot element. We will start looking for second pointer now. 8, I think, will be the second pointer in this case. To the right hand side of the second pointer, which is 8 in this case, we will look for a value which is actually less than 6. Now we have no values here. We are going to reach the pivot element itself if we go on looking for the whole array. So this condition has reached. Now again, the pivot element and the second pointer will be swapped. So 6 is now at the place of 8 and 8 is now at the place of 6. So scenario is 6, 7, 9, 8. Okay. Now your pivot element is at 6. I am not bothered about 6 now. Okay. So again, this array has been shortened. We have divided this array again in two parts, and now we are going to conquer it. So with this smaller array, I am again going to initialize a pivot element, that is 8 now. Okay. 8. And now I will again look for a smaller second pointer. Now second pointer, remind you again, that must be the value greater than pivot element. Now 7 is not greater than 8. I will move to next one. Now 9 is greater than 8. So this is my second pointer now. This is my pivot element. This is my second pointer. Okay. So again, the rule says that towards the right hand side of the second element, I have to find a value, if there is, which is actually less than 8. Now to the right hand side of the second pointer, we have no element which are greater than 8. We have reached the last point where we are going to swap the values of pivot element and the second pointer element. So 8 will be swapped with 9 and 9 will take place of 8. So I think 8 is now the pivot element. So I'll again disintegrate this particular array into two parts, that is 7 and 9. And as you can see, the pivot element, these are only single elements in these particular arrays. So we can say that they have been found out their rightful places. As in this case, we are left with only 1. Okay, because pivot element is 0, we are left with only 1, and it is the only value in this particular array. So it has found its rightful place. So if you combine all this, you will have the sorted array with you. Okay, now you can see that in the end you will have something like this, that is 0, 1, 2, 6, 7, 8, 9. So what I have done here is I have shown you the quick sort to the left hand side. So after the first one, okay, I think I have repeated all this, so no need to do this again. Yeah, we have already done that, so no need to do this again. Okay, I think we have reached the end of the algorithm explanation. All we have to do now is go through the algorithm itself. Now it may seem quite complicated, but it is actually not. What we have seen here already in those slides, which I have tried to tell you, is just explained in this particular algorithm. So first, what we have to initialize or call the function called quicksort. We have to pass the array and the leftmost index and the rightmost index. You can, if you haven't passed these two particular points, that is okay. You can find out by yourself. The leftmost index will going to be 0, and the rightmost must be the length of the array -1. So now if the leftmost index is actually less than the rightmost index, which is if you have initialized the array at the first place, and if that is unsorted, that is going to be, then you have to fix the pivot index. Okay. Now pivot index is being, for fixing the pivot index, what we have done is we have called some other function called partition. For that particular, let's go inside the partition first. So I have passed the three arguments to it, that is array, leftmost index and rightmost index. So I will set the rightmost index as the pivot element. That is what we have done. We have set the two element as the pivot rightmost index, if you remember from the beginning of the lecture. Now store index leftmost index minus 1. We'll move ahead to the next one. For I, leftmost index plus 1 to rightmost index, if element I is less than pivot element. So what we have done here is we have initialized in this particular line your second pointer, that is store index, that is leftmost index minus 1, that is starting from 0, that is minus 1. Now we will start iterating through a loop which will start from leftmost index plus 1, that is from 0, to the rightmost index, that is equal to length minus 1, or to the pivot element. Now if I found an element I which is actually less than the pivot element, what I will do is I will swap the second pointer with the the element with the second pointer. Okay, and then I will update the second pointer. Okay, and then again I will, if this particular for loop has completely ran out of its course, at the end will be at this particular point where to the we will have reached this particular point where towards the left hand side or right hand side of the second pointer we have no elements which are actually less than 8. So in that case we have to swap the pivot element with the second pointer. Okay. So this is what they have done here. We have swapped the pivot element with the element at the second pointer. Okay, and now I will return the new second pointer here, and again the same quick sort will be called. So this is a recursive way to write the quick sort algorithm. Now you have to imagine that, or start doing that with the help of an array, that like we have done at the beginning of the lecture. You have to put one array here, put your algorithm on this side and do it point by point. Okay, so I'll end this lecture here now, it's getting too long.